So for how many 2 by 2 matrices A, it's true that A squared equals identity matrix, and then we will need to answer the same question but for n by n matrices where n is larger than 2. Well, let's consider 2 by 2 matrix A where A equals 1, some number A, O, negative 1. Then A squared equals A times A, so matrix A multiplied by matrix A. So let's find the product matrix. We get 1 times 1 plus A times 0, so it's 1. Then 1 times A minus 1 times A plus A times negative 1, so it's 0. Here we get 0 times 1 minus 1 times 0, so it's 0. 0 times A minus 1 times negative 1, it's 1. So as we can see, this equals identity matrix. Then all values A satisfies this. So for all A, this matrix would give us identity matrix if it's squared. So then there are uncountable number of A's satisfying A squared equals I. So the uncountable, let's write it down, the uncountable number of A satisfy A squared equals identity matrix. So there is uncountable number of such matrices. Uncountable number of matrices. Is this? Well, now let's similarly do that for n by n matrices. For instance, if n equals 3, we can have A equals 1, A 0, 0, negative 1, 0, 0, 0, 1. In this case, A squared also equals identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Identity matrix. So for n equals 3, there also exist uncountable numbers of numbers A for which A squared equals identity matrix. So there exists uncountable number of matrices. So that means that this satisfies for all n by n matrices, there is uncountable number of matrices which satisfy A squared equals identity matrix.